Hey everyone, this is Matt with Learn Everything About Design, and in this video, we are going to dive into configurations, display states, and even design tables inside of Solidworks. Now, we are not going to be able to cover everything in this video. Fair warning, will probably take about 30 minutes because there is a lot to cover. But we're going to get into doing this at the part level and understand the nuances of the way in which we model a design and how that's going to affect our design tables as well as our configurations, derived configs, and even display states. So the first thing that we're going to do is we're going to get started modeling a basic example. This is just going to be a plate. And what we're going to do is we're going to talk about the way which we model, the way which we actually define the dimensions, and how that affects us. So if you want to follow along, we're going to be using the inch unit system. You don't have to use inch, it can be metric. Just make sure that you are comfortable creating some basic features. So to get started, I'm going to sketch on the top plane. I'm going to use a center point rectangle. I'm not going to manually enter dimensions just yet because there's something that we need to do. And I'm going to add a circle at the origin. So using our dimension tool, the first thing that I want to highlight, the thing that's going to help the most if you use this modeling approach, is we're going to enter a value, 10 in this case. But for the dimension, instead of leaving it as D1, we're going to type in width. So what we do in SOLIDWORKS when we rename a dimension here is we're changing the name of that dimension in the back end of the program. The reason that that's important is because it makes it much easier for us to reference downstream. For example, I'm going to leave this one as D1 and just hit 6 there. And then I'm going to have a diameter value here. I'm going to set this to 3 inches, but I'm going to rename this diameter. So after we leave this, I'm going to go to Extrude. And I'm going to extrude this out, and this is the second thing that we need to be aware of. Whenever we're configuring a part, we need to think about which features we need to be able to turn on and off in various versions of that part. For example, it might be very easy for us to extrude this plate with the hole already in it. But if there's a configuration where that hole doesn't exist, we cannot include it in the same sketch. So, we can have it in the same sketch, we just can't have it in the same feature. So we want to make sure that we do include that here. We share that sketch or we reshow it. And then we extrude cut the hole through the center of the part. We're going to flip the side, go through all, and say OK. And I'm going to rename this feature. I'm going to call this one hole. And I'm going to call this one base plate. And sketch 1 is OK, but the names of our features as well as our dimensions and even our sketches, those are important because those are going to display in a table. And if they're just sketch 1, extrude cut 1, it doesn't really mean anything to us. But now that we've got a basic part, we've got a sketch with a couple dimensions, we've got some dimensions we renamed, and we've got a feature, let's talk about the ways in which we can start configuring. Now, there's a couple ways that we can do this. Some are easier than others. But at the very basic level, the first way that you might explore this is by right-clicking on a sketch and selecting Configure Feature. When we do this, the first thing that pops up is just Suppress. Now, that doesn't really mean much, but if we check on this little drop-down box here, this allows us to pick other things that we want to configure. And here is where renaming those dimensions comes in handy. D1 doesn't mean anything to me. I'm going to pull the model down because this actually will update live. But D1 doesn't really mean anything to me. Diameter does and width does. Those values make sense, and this is why it's so important to rename these. So if you try to rename it here, so I'm going to call this one length, we are able to rename it here. If we say OK, and we go back into this sketch and double click on this, you can see that it did rename it here. But as you might imagine, doing this for dozens, if not hundreds of dimensions could be incredibly difficult, if not impossible, to figure out what those dimensions were. So at the very basic level, when you're creating a design you want to configure, make sure that you do take the time to rename your dimensions at the very least. If you don't rename your sketches and features, that's okay, but renaming those dimensions is going to go a long way. You can also see here that it will display the name underneath. So you can see width right there is showing as 10. This one here, length, and the diameter here as well. So being able to see those on screen can be very helpful. The next thing that we would want to do is figure out how to add new configurations. And that can be done a couple ways as well. So the first way that we can do it is by simply clicking in here and adding a new configuration. I'm going to call this one large plate. Now inside of the cells in large plate, we would want to increase these values. So instead of 6, we'll make the length 10. Instead of 10, we'll make the width 15, and I'll leave the hole diameter the same. I'm going to click this rebuild all configurations so that they are already ready to go once I exit this, and I can say OK. Now inside of my configuration manager, I can double click on large plate. It's already rebuilt. It's already ready to go. I can double click on default and it goes back down to that original size. So this is the easiest and quickest way to begin creating configurations. The other way that we can do this is by right clicking here and selecting add configuration. So I'm going to call this one maybe medium. I'm going to leave all of the options on as default, noting that this suppress feature in the advanced section is incredibly important, and I'll explain how it works in just a minute. So we'll say OK, and now we've got a medium feature. A couple ways that we can configure this. We can right click on the configuration table and select show. This will show anything that we've already determined as a configurable thing, in this case these dimensions. So maybe for the medium plate, what I want to do is say 12 inches by maybe 8 inches. I'm going to rebuild all configurations again, and the only reason I'm doing that is because as your configurations become more complex, rebuilding them each time you click on them can be kind of a pain. So rebuilding them while you're making those configurations can help you find any potential problems quickly. So now we've got large plate, we've got a medium plate, and the default, which is a bit smaller. So those can all be configured in that way. You can also right click on a feature, not just a sketch, and select configure feature. Again, the dropdown will highlight anything that we may want to be able to configure. In this case, D1, I'm going to call this EX height for extrude height. And maybe for the default plate, maybe that should be 1 inch. For the large plate, maybe it should be 2 inches. And for the medium plate, maybe 1.5 inches. Again, I'm going to allow it to rebuild all of those. Though I don't really need to for such a simple example, just kind of habit. And now I can go back and forth between each of these. And now they change thickness and they kind of move around. So that is the basic way that you can get into creating configurations. Planning your designs at the start, naming your sketches, naming those dimensions, and even naming your features, all are going to help you downstream. Even though you can do it while you're configuring, it makes a whole lot of sense to do it initially. The next thing that I want to highlight here before we move on is something called derived configurations. So let's go to the medium plate, for example. In the medium plate, we're changing the length, the width, and the thickness of the plate. Now, in some instances, we might want to change some features, but inherit those others. So what I mean by that is for the large plate and the medium plate, those size references are important, but maybe we want a variation that doesn't have the hole. Instead of making an entirely new configuration, we can create what's called a derived configuration. So I'm just going to simply call this one no hole. And that is going to inherit anything that we have in medium. And what I mean by that is I can come to this hole and simply select suppress. And then if I go back up to the medium, the hole is there and the hole is gone in the derived or that sub configuration. Large plate should still have it, default should still have it. But again, I can make these derived configurations. I'm going to call this one no hole as well. You can see that it gives me an error because it already exists. So we'll create a derived configuration. I'm going to call this one no hole default. And then again, just come over and suppress it. So now we've got a version of the default plate with and without the hole, a version of the medium plate with and without the hole. The last thing that I do want to mention when we're talking about basic configuration functionality is something called display states. Now, display states can be universal across all configurations, or they can be tied to configurations. So what I'm going to do is I'm going to rename this default. Actually, no, let's go ahead and add a new display state, and we'll call this new display state red, and we'll add another one, and we'll call this other new display state blue. Now with display states, what we're doing here is we're going to change the color of the part. I'm going to go to the red display state. I'm going to change this one to a red plastic material and drag that in, click that. And then the default is still gray. Now these currently are not linked to a configuration, which means that if I go back to any other configuration, then they are going to continue to stay blue or red or whatever. But let's say that you want a derived configuration that is a large plate and that it's maybe blue. What we can do is we can use configuration specific colors. So I'm going to just give this a blue color here, and we're going to say OK. And if I change my display state here and I go to this one here, you'll notice that it's not actually changing to blue. And that's because using a configuration specific color it's not applying to the display state here until we go back to the default. So the default here is blue. If we go back to this one here, let's go back to this one. So it's using this blue color here as its default. What we really want to do when we start to configure colors is we want to use a configuration specific color. So if we check the properties of this, we want to link display states to configurations. So if we link that display state to a configuration, this means that as we go back and forth between display states, the colors are going to change, or the display is going to change. And what we can do is we can change it to things like a wireframe display. So for example, if we come down to the display state for the solid body, we're going to say wireframe. So if we go back to the default, it'll show it as shaded, and this one will show it as wireframe. This one will show it as red, this one will show it as blue, and so on and so on. So it takes a little bit of getting used to because it's not always very clear how these things are linked together. But with a little bit of planning and a little bit of work, you can make a lot of functionality built into a single part file. All of these configurations and display states are accessible when you insert this part into an assembly, which makes it extremely powerful at that level. And there are more things that we can do with design tables and configurations at the assembly level, which we're not going to talk about in this video. But this isn't all. Now that we've taken a look at sort of the most common approach to using configurations and derived configurations and display states, let's start a new file. And let's talk about another modeling approach that's pretty common. So what we're going to do here is we're going to start a new design using global variables. Now, this is something that's extremely powerful on its own. I think global variables are a great modeling approach, especially if you're preparing for things like the Certified Solidworks Professional or Expert exams. You get a design or a drawing and you have dimensions listed as A, B, and C. Putting those in as global variables and changing them here and updating an entire part is the way in which you are more efficient on those types of modeling tasks. So what we're going to do here is we're going to say length, tab over, and just have 10 inches, hit enter. Width, we'll make that 5. Height, we'll make that 1. And a whole DIA for diameter, and we'll make that 2 inches for right now. So these global variables are able to be accessed when we're creating a sketch. So we'll start a new sketch, center point rectangle just like before, but this time if I hit equals in the dimension dialog, let's do this again because I hit escape. If I hit equals in the dimension dialog, it's going to open up my global variables for me to just simply select things like length. We'll do it here, hit the equal key, global variable width, and we'll add that center diameter circle here. I'm going to have to give it a value and edit this. We'll hit equals and we'll give this a whole diameter value. Next, we want to extrude this. Again, we have to think about the ability to suppress and update. So I want to go into my profiles in the selected contour and I want to bring everything in. And then here we'll hit the equal key and we'll set that to our height value. So next we want to show that sketch again and basically creating the exact same part. So we'll do an extrude cut, make sure it's going through all. And now we've got everything that we need to configure the same exact file. But the problem that we have here is if we right click and configure the sketch and we use the drop down, these are listed as D1, D2, and D3. They're not bringing in the global variable names. So if you do happen to model with global variables and use this approach, the way that you want to configure your design is by going into Tools and into your Equations Manager. And note that once we have configurations, we'll be able to configure these in here. Now, the way that you add a configuration depends on your approach. I'm going to come up here and add them on my Configurations Manager. So I'm just going to say small, and we'll add a medium and a large. And that way we've got 3 different configurations that we can work with. Once we have our configurations, inside of our Equation Manager, we now will see a drop-down box. We can pick from the various configurations, and then once we select our dimension, on the right-hand side, we can configure it for a specific configuration. So for the small configuration, I might want this to be 5 inches wide. And for the width, maybe I want this to be 3 inches. And the height, maybe I want this to be a little bit smaller, and we'll set it at 1/2 inch. And then the hole diameter, make that a little bit smaller as well. We'll set that at 1 inch. Remember that this is configuration specific. So in the top right, I'm going to click on medium. I'm going to say OK to allow it to rebuild. And then I want to configure each of these. So maybe 10, 5, 1, and 2 is OK for medium. The large plate, this is where I maybe want to make them a bit bigger. So we'll do 15. We'll make this one 10. We'll make the height 2 inches. And we'll make the hole diameter a bit bigger as well, 5, and we'll say OK. So that's the way that you would want to approach making your various configurations if you use linked parameters or global variables. So now that we've covered the basic approach for configuring global variables and also configuring basic parts, let's talk about design tables, because design tables are extremely helpful, and there are actually a couple different ways that we can do this. So first, I think I want to give a semi-honorable mention to the configuration publisher. Not something that I think makes a whole lot of sense when you're a single user or and just a couple users. But Solidworks does include the configuration publisher as well as things like the property tab builder as more of a UI-based element that you can use over here, for example, in the task pane. So what we would do in those cases, we would drag the variables that we want to control into this configuration publisher, and then we would preview that. So for example, we could pick from a list of different sizes, and we can configure whether or not things are suppressed. We would have to name them. So for example, checkbox 1, we would call this something like whole state, for example. And then on here, you would see whole state or suppress whole and so on. So you could use this to update the model. But again, I don't really use those types of things. The property tab builder, it's a lot of setup work. And if you're like a CAD admin or if you're working in a large organization where a lot of people use these tools, yeah, it totally makes sense. But for the most part, I think getting comfortable with design tables in Excel is a much more powerful tool. It gives you a lot more flexibility than that publisher has. So the way that we do that is we go to Insert, Tables, and select Excel Design Table. Now, a couple things that we should note here. Auto create is the most common option. You can create some from file. So for example, you could save out your design table as an external Excel file, and you could use it to build other files if you want. The option to block model edits is incredibly helpful if you are sharing this with other users. That prevents them from changing the dimensions in a sketch or in the equation manager and updating a design table. It requires them to go to the design table. The option to enable cell drop-down lists is incredibly helpful for things like display states. So for example, if we have display states that link to configurations, then for example, where we have display state here, we've got a drop-down where we can select available display states based on the configuration-specific available display states. So for example, blue or red is available here. We could change it to red instead of blue. Some of the other ones don't have additional display states that we can select from, but those are all available. Now, it's important to note that this is Excel inside of Solidworks. It's still in the Solidworks application, even though you've got the Excel sort of ribbon toolbar at the top. You can also open these now that we have an Excel design table created. We can open it in a new window, and this to me is far easier to deal with than having it directly native inside of Solidworks. So what we can do here is we can add new configurations. So for example, I'm going to do a extra large plate. And the extra large plate doesn't need everything filled out. You only need to fill out things that you want to change. So if I don't fill out, for example, the color, it'll just inherit the default color. For the display state, if I want it to inherit a display state that's available, I can type it in. Once it generates the new configuration, the drop-down list will be there as well. But let's say that the length, maybe I want to make this 15, make this 20, make the height of the plate, in this case, I'll make it 3 inches, and S for suppress and U for unsuppress for the state of the hole. Let's say I want to include the hole, I'm going to just leave it blank, or I can put a U for unsuppress. Once I'm done, all I need to do is close out this Excel document. It'll tell me that it created a new configuration, and that new configuration will be available, extra large plate, inside of here. And I can still work with the configurations here. For example, if I wanted to suppress this hole, it's just going to tell me this is going to update a cell inside of my design table. It's not going to prevent me from doing it because I didn't block model updates. So it will allow me to do this, and it'll allow me to change the cell in the design table. So if I come back and I open the table in a new window, now it's simply just going to tell me that it suppressed that hole. And you can see here, S is suppressed, U is unsuppressed. So we can change it in either place by toggling S or U. Again, leaving it blank will default to unsuppressed. That's just the nature of how it works. We'll allow it to update, and then again, you can work with it in either way. So I know that was quite a lot. We're 22 minutes in, but there is a lot inside of configurations. There's a lot inside of design tables, and we really are only scratching the surface. The main place that I see this as extremely helpful is actually when you start to get to the assembly level, because you can configure whether or not a part is suppressed or unsuppressed. You can configure things like the mates between components. You can change the mates or the distance or values of those mates. You can change the color, the appearance, the display state. All those different types of things can be configured at the assembly level as well. But what I would suggest if you're trying to get into dealing with configurations, dealing with display states, dealing with design tables, start with something simple like this and play around and get comfortable. There are more downstream implications for things like detailed drawings and bill of materials, but at this level, I don't think it's important to get hung up on those details. Just get comfortable and familiar with your modeling approach that you want, whether it's global variables or not, and the way in which you configure those features. If you have any questions on this, or you want to see more on design tables and the functionality with configurations, then please let me know. As always, thanks for watching, and we'll see you in the next one.